Welcome everybody in the name of IRISCC to this fifth session of a webinar series on the research infrastructures comprising IRISCC. As you know, IRISCC aims to integrate climate change related services from 14 European leading research infrastructures. And today we do have the pleasure to have with us Niku Kivekas from ACTRIS ERIC, presenting as ACTRIS, which is the aerosol, clouds, and trace gases research infrastructure. And we also have the pleasure of having Ulf Malest from the UFZ, which is the Helmholtz Center for Environmental Research, who's going to be introducing ELTER, which is the Integrated European Long-Term Ecosystem, Critical Zone and Socio-ecological Research Infrastructure. As in previous sessions, we're going to be recording this introductory part, and then we are going to stop the recording for the part concerning the questions from the participants. And again, as in previous sessions, we've been approaching the speakers and asking if they can explain to us what their research infrastructure is about and how this research infrastructure fits in the context of IRISCC. And finally, if they can give us some climate change risks-related examples coming from their research infrastructure. So I will not steal more time from them. I'm going to stop sharing my screen and I'm going to give the floor to Niku Kivekas from ACTRIS. Niku, wherever you are, the floor is yours.
Thank you very much. I will share the screen. Now, yes, and please confirm that you now see it in the full screen mode.
We can see it in full screen mode, yes.
Yes, so I'm Niku Kivekas, working at the ACTRIS head office, and I'm here presenting the aerosol, clouds, and trace gases research infrastructure, ACTRIS. And this presentation is based on this very same structure that Benyat just introduced. So starting from what ACTRIS, what is it about? And so ACTRIS, aerosol, clouds, and trace gases research infrastructure. So obviously this should already tell that we are looking at the atmosphere. More specifically, the fancy sentence is that ACTRIS is looking at short-lived atmospheric constituents and processes leading to the variability of these constituents in natural and controlled atmospheres. What that means in practice? Well, we have the three components here: aerosol, clouds, and trace gases. And all three of these we are looking from the in situ measurement techniques, but also with remote sensing. And to be more specifically, with aerosol, we mean in all like small solid or liquid particles in the air. Well, usually there is water around them, but not really the raindrops, but anything in the particles suspended in the air. The clouds, we are not looking clouds from the perspective that where are clouds and what they look like. It's more on the cloud microphysics, cloud droplets, and further on to the raindrops. And the trace gases, more specifically reactive trace gases. So any atmospheric gases that have very small concentrations and are reactive. So we are not looking at things like carbon dioxide, that's on ICOS. We are not looking at things like oxygen, nitrogen, but we are not looking at things like helium because these are not reactive gases, they are very inert. We are looking at those that are present there in small amounts and actually react with things, therefore affecting the atmospheric chemistry, air quality, and air pollution impacts. And with in situ, I mean, it means basically that we are looking at air where the instrument is, and remote sensing We are focused on ground-based remote sensing, so we are looking upwards with different radars, etc., for specific purposes. And then, what are really the key scientific themes we are looking for? Some of them are like the aerosols and their impact on climate. You can see in that picture actually a nice aerosol layer that looks like somewhere in Italy. Cloud formation and and the atmospheric interactions related to that. Atmospheric chemistry, but also observation and technology development, data synergies with modeling and with satellites, because we use similar instruments than there are in the satellites. Actually, usually because we are not payload limited, we can have higher quality, but where the satellites are looking down from space, we are looking up from the ground, and we can use this for the calibration and validation of satellite measurements. And then there is also the different innovations and environmental monitoring related to air quality, where we can contribute. And how it's structured, we have these national facilities, how we call them. These are different measurement stations, both observational platforms where you observe the atmosphere as it is, or exploratory platforms, which are like atmospheric simulation chambers where you can affect the conditions of the air where you do the experiments, or mobile platforms that you can take where you actually need to measure specifically. And then we have the central facilities, head office, data center, and 6 topical centers. And if you look at what these topical centers are, you clearly see that there's aerosol in situ, cloud in situ, trace gas in situ, aerosol remote sensing, cloud remote sensing, trace gas remote sensing. So for each target species group and each kind of measurement approach there is one. Where the national facilities are financed with their hosting countries, the central facilities are financed such that approximately 30% of their funding comes from ACTRIS ERIC, and that is collected from the member countries of ACTRIS as membership fees. Then, how that really works, the topical centers. So here, this is where they're defined the harmonized methods and the instruments are calibrated. Then at the national facilities, these instruments are used for provision of data and also some parts of the data production or automatic data processing. And then it goes to the data center where they take the curation and archiving of the data and also provide the data to the users. So this is the chain, how the quality is kind of controlled in ACTRIS, how we can provide high quality and harmonized data. Yes, there are currently 18 countries as members in ACTRIS ERIC, with approximately 75 research performing organizations in those countries participating in various roles. We have the 8 central facilities I mentioned, 119 national facilities, of which 84 are observational platforms, so measurement stations, and 35 are exploratory platforms. Practically half of them simulation chambers, and the other half mobile platforms that you can take where you want to measure there. And just some numbers here, or things at a glance. So yes, we are very recent ERIC. Just 3 years ago, we got the ERIC status for ACTRIS. These are the 18 member countries. Newest one of them, Greece, that actually joined this month. the facilities. And ACTRIS is one of the 3 ERICs led by Finland. There are ACTRIS, Eurobioimaging, and ICOS, which I have to say it's considering that Finland has approximately 1% of the population of Europe. It's leading 10% of all the European ERICs. But now, how does this thing called ACTRIS fit into IRISC? Yes, as mentioned, we have these observational platforms, measurement stations all around the place. Really, I apologize for there should be square kilometer, not square meter here, but since this is a picture, I could not modify it. So we are looking at Europe, also beyond, but as you see the location of the stations, mainly Europe. But really, from very sparsely populated areas to quite densely populated areas. From very dry areas to very wet areas. Areas that have very different vulnerability to climate change. From kind of climate zones, we are looking from tundra to the Mediterranean. We have from the vegetation from Arctic to subtropical. We have from the coast. I actually need to check whether we have actually one station below the sea level in Netherlands to high altitude. And we have from forests to agriculture to urban areas. So we are really looking at very different environments in Europe with these observational platforms that provide continuous long-term measurements. Then is the other side, the exploratory platforms, especially the simulation chambers. We have them in various areas. We have the where we can, like in forest areas, suburban areas, industrial hotspots, also with others. Then we can use them for indoor air. We can even simulate the atmosphere of Mars with these chambers. We can study cryosphere, marine atmosphere, desert dust, clouds, also like clouds in a chamber. So within a predefined volume, create our own clouds to study it. So from now IRISC's perspective, looking at climate change, I think there is quite a bit to offer. So we have the data, long-term data from these facilities. We have the data and also access to these exploratory facilities. There's data curation and storage, instrument quality assurance and quality control, such as calibrations, provision of measurement protocols and guidelines, and training. These are kind of the key services that ACTRIS can provide from data. Actually, ACTRIS database, ACTRIS data center is led by Nilu in Norway. We have present not only ACTRIS data, but we can also connect to other data that is stored there, such as like the EBAS data. So we can have actually quite high amount of atmospheric data available through ACTRIS data center. Part of that is ACTRIS data, part of that is other data hosted there. And these are clearly separated. The data is available for free from the data portal, and within ACTRIS, all the data for a given parameter is provided using the same measurement and data processing protocols, so they are truly intercomparable. It's also possible to process the data online with virtual tools, so you don't need to download everything. And we have over 100 atmospheric variables available there. The other key service we provide is access. So yes, you can come to our facilities, not all, but many of them, with physical, partly also remote or hybrid access, so that to do your own experiments, where we use it is, this has been used is for like instrument testing in different environments and different conditions. Also, the manufacturers have used this access for testing their instruments. Then field campaigns or other experimental campaigns, or you can bring your own instrument and deploy it side by side with the regular ACTRIs instruments to monitor the performance. And access to the facility is provided mainly free of charge, thanks to TA programs, and it's competitive, but we can also, like for the commercial actors, we can also provide access so that it's not going to go through the TA process, but rather they pay and we service them. And in IRISCC, there are altogether 21 ACTRIS platforms that provide TA. Many of them are also in other infrastructures, actually most of them. And these 25 include 13 measurement sites, 5 simulation chambers, and 5 mobile platforms. Then let's continue. So what else is there? Well, the expertise we have in IRISCC, the TA management is done on the ACTRIS PAS platform, hosted by CNR in Italy, in work package 8. And then the virtual access management, there the key actor from ACTRIS side is Nilu, that is leading the ACTRIS data center. And also ACTRIS is helping in the coordination and management of the project, supporting the coordination office. And that is from ACTRIS Eric. Actually, that's mainly me. Then looking at the project structure, where ACTRIS appears in IRISCC. In work package 1, we are included, but we are leading work package 4. I am the work package leader here. Then we are included in 6 and 7, but again, leading number 8, led from Italy, is CNR, and here it's Rosa Petracca. And from work package 9, the leader is Lise Eden Murberg from the ACTRIS data center. So we have a strong role in the process also from the structural point of view. And then included also in work package 10 and 11 as partners. Then going to the examples of climate change risks and the cases that ACTRIS can provide. Basically, how ACTRIS can contribute, there are 2 things. First one is the measurement data. We have the continuous long-term monitoring of atmospheric chemistry over most of Europe that would reveal diurnal, weekly, and seasonal variation and trends. Also, background values of many of the monitored air quality parameters. Like you are measuring something like particulate matter in a city, and you need to include what is actually produced by the city, then you need to somehow exclude the background, and that is something we can provide. And then there are we can provide rapid information on special events such as wildfires, dust storms, volcanic eruptions, because we have a good coverage of measurement stations over Europe. The other side is then the exploratory part. We have mobile instruments that you can ask access to, so that the instruments can be deployed where you actually need to measure. Then we have the atmospheric simulation chambers, where you have a controlled and user-defined atmosphere where you can study the different processes. So let's say from climate change point of view, we can provide a double concentration of CO2 easily, and then you can look at the atmospheric chemistry and the other processes, that how is that affected. And then testing of instruments and their performance in various conditions. And then looking at some actual examples of how ACTRIS data or ACTRIS expertise is used in climate change related risks. I didn't actually need to go very far, because in IRISCC work package 4, which I'm leading, there are the demonstrators, and 2 of them are such that they actually directly use ACTRIS data. Case number 1 here, risk on human health in urban areas during heat waves and associated with deteriorated air quality. And here, this is something that is led by IRENE. They provide the exposure data and kind of the population data. We can, from ACTRIS, among others, provide relevant air quality parameters there, so that the user has a variety of data sources for the different atmospheric constituents and air quality, and then can connect that with population data and exposure data to get in and to work on a virtual research environment to see how people are exposed to these, like air pollution, and also if they have access to health data, then how that would affect. The other case is also from IRISCC work package 4, risk on multiple systems due to wildfires in Europe. And again here, the idea is that when there is a significant wildfire, we automatically collect the data. There's automatically the automatic collection of data from those measurement sites that are affected by the smoke plume of the fire, and then a specific data set for each fire is automatically generated, and then that can be used for studies, again in a virtual research environment. And that is actually, and these 2 demonstrators are such that they are to be launched in September this year from IRISCC. So then, as both of these are virtual, you can all have access to these and see what can be done. And with that, it would be the time for questions and answers. But as confirmed by Benyat in the beginning, we are not having the questions quite yet. We are first also going through the eLTER presentation and then having the questions together.
That's
and
right,
with that,
Nico.
I thank you very much.
Thank you for your presentation. This was a very comprehensive introduction to ACTRIS and also to your role within IRISCC structure. You do have already a question in the chat, but we will go later on through the questions. Before moving with eLTER, I just wanted to say to the audience as well that you will find the different services that ACTRIS is providing in the link that it's been put in the chat, and you can also find it through the website. Nico was also referring to IRENE, which is another research infrastructure we've been introducing in a previous session. So you're more than welcome to check that session in our YouTube channel. And Also, I wanted to say that a couple of days ago, we in IRISCC ended up the third call for transnational access. But there is this fast track access that it can be applied anytime if it happens that we do have some climate change related ongoing risk. And this came to my mind because Niku was talking about wildfires in the second demonstrator. Unfortunately, it's also one of these events that you can experience in summertime in Europe. So if you're interested or you do research in wildfire, for example, maybe it's interesting for you to check the different services that might be related with this topic and access services or different facilities through this fast track. Otherwise, just say that IRISCC is going to open the next 4 call for the transnational access in around summer in July. So once again, you're welcome to check the different services that are given in the catalog of services, not only from ACTRIS, but also from the remaining 13 research infrastructures, and come up with maybe a proposal might be interesting for your own research. So with these advertisements that I wanted to put in here, I'm going to move forward. I'm going to give the floor to Ulf. Ulf, whenever you are ready, the floor is yours.
Thank you, Benyat. Then let me take over and let me share my screen, and you let me know, please, when you can see it.
We can see it now in presentation mode.
Perfect. So then also, good afternoon from my side. I will say some words on ELTER in this IRISCC webinar series. Same structure as before, some words on ELTER in general, then something that you can, what you can do with ELTER data, for example, in the climate change context. And then, of course, also something what ELTER is really doing in IRISCC. It's always difficult to start a presentation sometimes. And of course, when you talk about ELTER, you could start in different levels and from different perspectives and angles. I chose this time to talk about the S3 level, of course, because we talk about research infrastructures on a European level. So S3 comes to my mind first. And I'm guessing you all know what S3 stands for. It's the European Strategy Forum for Research Infrastructures. And I'm not sure if you happen to know what this, the different details are, how you get actually into the S3 landscape as an infrastructure. And it's actually quite easy because if you have an idea, you simply apply to get on the roadmap of S3. And this has happened for ELTER back in 2018. And from that time, when you're on the roadmap, you have 9 years of time to get to a full entity, which in many cases, as in ACTRIS before, it's called ERIC, the European Research Infrastructure Consortium. But again, this has to happen within 9 years of time. So if you now simply sum up or add to 2018, 9 years, you end up in 2027. Simple math, which means this is the time where also ELTER has to become this ELTER ERIC. So as you can see from my words, we are not yet there. We are in the last stages to get this ERIC, to be this ERIC. But we are, like IRENE, for example, still in the preparatory phase, as said, in the last steps. So very close, on the edge even, to be the ERIC quite soon. If you now look into what I shown here into the S3 landscape and the domains, you see on the left-hand side this environmental domain, where ELTER is actually mainly associated to. You will see that you have ELTER and 3 spots and 2 spheres. One is the geosphere and one is the biosphere that S3 puts ELTER in, contributing to the sampling and observations in general, but also on the ecosystem structure and functioning and ecosystem services. And ELTER is also associated to the second domain, namely the health and food domain, where apparently we are in the biological and resource and production system. Of course, this is a bit arguable whether or not ELTER could be in different kind of subdomains or even spheres. Personally, I would see also ELTER in the biological science subdomain up here, also in the different spheres. And I will come back to this, why I see it in an arguable way in a few seconds again. if we now change a bit, before we do that, actually, one thing that is missing from this categorization from S3 is a very important aspect that the S3 landscape analysis outlines quite prominently in their analysis report by saying that eLTER is also dealing with the socio-ecological approach to studying integrated human nature systems, and with the commitment to integrate stakeholder knowledge. That is quite unique because many do not look at the entire system and do not really include directly stakeholder knowledge, and by that also the human nature system. That is one of the unique aspects eLTER deals with. And now let's maybe change a bit the perspective away from S3 now, how eLTER sees its mission. And here we have an extract of the mission statement. What we see here and can read is, of course, it's a pan-European in situ research infrastructure, which will serve, of course, multiple scientific communities with high-level center facilities. And that's the main point to stop for a moment. And to emphasize once more that these facilities and the distributed, well-instrumented eLTER sites and social platforms are central. So what you see on the right-hand side are in green the sites, in orange the platforms, and eLTER differentiates these two because for the sites, it's a very constrained area. It could be, for example, like a peatland, it could be a grassland, for example. But the socio-ecological LTS, S standing for socio-ecological platform, observes, like the sites, many different variables in the different spheres, but it always has the socio-ecological aspect involved. We have in eLTER around 200 sites, as you can see on the map, also quite well distributed across Europe, also across different gradients, and it also covers different habitats from terrestrial to freshwater to transitional waters. The same is true for the platforms. Here again, this one distinguishing factor is that platforms are not quite site constrained or spatial constrained, but they are usually comprising regions or catchments or larger areas. And these platforms are exactly what as we pointed out, because here happens is the research on the human nature interaction. So they act as living labs in a way, where we also could test, of course, some regulations, for example, where stakeholders are then involved and where we get their views and their needs also as well, and the impact on them as well when it comes to the to regulations, for example. At those sites and the platforms, what we always do is, of course, to collect data, harmonized in this case, harmonized on observations, which are across all the 5 spheres. You can see on the right-hand side here, across the different atmosphere, the biosphere, the hydrosphere, geosphere, and that's the reason why I'm saying before, we could argue whether or not S3 has completely gotten the entirety of eLTER. We have more than just biosphere and geosphere that S3 has assigned us to, of course, and within those spheres, we do collect those standard observations. These are 63 currently, and has been a 5-year-long process to really agree with the various stakeholders and the various experts on what those observations would include, what variables, what resolutions, what accuracy, and even to, at the end, of course, define certain protocols. We do try to fit as many protocols in here in our observations that already exist, whether it's from other infrastructures or from organizations, for example. For some, we had to define protocols ourselves, and we are currently in the last steps to really finalize those protocols. The outcome of that has just been published. If you want to have a look, there is now the publication down here from Stefan Zacharias just a couple of days ago. The publication where the 63 SOs are defined and described, and also how we actually got there and what the main benefit would be for science. And of course, as always, we would take those information that we collect from the ground, the in situ data, just as ACTRIS described before, and would integrate those with modeling exercises and also with remote sensing to create added value products, also standardized in a way and make them available as free data. And here comes the second unique characteristic of eLTER, besides dealing with the socio-ecology as well, which is what we call the whole systems approach of research and observations at those sites and platforms. So what has been said before is we do collect information across the different spheres for all the different sites and platforms. So we do that for the 200 sites and the 50 platforms we have. And we bring this together in a harmonized and standardized way. And at the end, there will be central services that really bring also you as a users the benefit to grasp this information, grasp the data per site, integrated also, of course, with the remote sensing and also with the modeling data sets in a so-called information cluster. And that is something that is not yet publicly available, but the first pilot is existing already. And I will show that in a few seconds as well. So what I've been showing is basically subsummarized in this graphic here. So we have the network, the different sites and platforms on the one hand side. We have the different services that will be provided through in our wording, it's topic center and head office. And all this will be available to you through a single access point, which is a service portal where you can either access the services or the data and make that available to you directly. Similar to also ACTRIS, we have those, again, we call it topic centers, not topical centers, but those 7 we will have most likely in the near future. And they will deliver 47 services. And of course, I could have now listed the 47 services, or I could have grouped them in those that you can see here. I will not read them out loud completely because it's just also too many, but I will focus on 2, one being the capacity building and service and training. Because there is already the eLTER YouTube channel where you have various videos of trainings, whether it's on data management or data publication or the TA as well, or others you can see online if you want to. I can share the link directly in the chat after my talk. And the second thing here in this regard is that we will also have a project that deals exactly with this training aspect, trying to really elaborate a bit more on what is needed, providing targeted training, including documentation, including training material, really completely targeted and also tailored to the users and not just from top down. The second aspect is the data access service aspect. Here, that is something that is, I think, quite important for many of you. Just as kind of little side story here, the access to the data you can have through the so-called DAR. eLTER is, I think, one of those entities that love to have abbreviations. DAR stands for Digital Asset Register. Once you go to the URL or the QR code here, you will be redirected to the portal, to the register. Currently, we have more than 3,000 data sets available in DAR. You can explore it for yourself. And from the category, from the register, you can also, of course, get the link to the data directly. And in case you're not finding what you're looking for because you have a certain study in mind, for example, you're going into DAR, there's nothing you can find for your purposes, I would encourage you to also have a look at the marketplace. Here you have the chance to really place a request that really focuses on your data, so what you would like to have for your study, whether it's on a very local or on a continental level. And you will reach easily all the 150 currently sites and platform coordinators we have in eLTER, which may have your data. So that's an easy way to really get in contact with those data providers who might be able to help you with your research. So again, I encourage you to go there. And if you have something in mind, do not be afraid to get in contact with us. And now, maybe a little teaser. I mentioned before the information cluster. That's going to be the one of the central elements for eLTER, where data can be explored, also visualized. We talk about really data sets from the modeling. We talk about data sets from remote sensing. We talk about time series data. of various variables across the standard observations and across the spheres. That is currently a pilot, not yet publicly available, being tested currently, but hopefully also available soon. And from here, you can, as said before, you can visualize, you can explore data, and you can even put those information into a virtual environment to further analyze with your needs and your purposes. This is what I wanted to say about eLTER in general, and also give you some teasers with the information cluster. I would now go to the what can you do with all this plethora of data that is available. And I would focus on two different studies, one more on the larger scale, continental scale, one more on the regional and local scale, focusing on the socio-ecological aspects eLTER covers. So the first study is a study by James Sinclair from Senckenberg and colleagues, and they wanted to identify the improvements in the equality of ecology of European rivers. So the aim was really to characterize the change and the anthropogenic impacts, and to define certain trends from 1992 to 2019 regarding the quality of those rivers at three scales: continental scale, country scale, and site and spatial scale. The data they used was riverine invertebrate biomonitoring data sets from 1,365 sites. Among them, there are quite many eLTER sites as well, across 23 European countries. What you see here already now on the slide is the results in the upper part, the scale, the trend on the continent, where you can clearly see from the beginning towards the 2010th a positive trend. So there's a clear improvement in quality, owing, according to the authors, to the European policies introduced in the 1990s that reduced the pollution, for example. If you look in the lower part to those graphics, you see directly that that's for sure so for many countries. So many countries really display the same positive trend. Others may have, let's say, a rather stagnant trend or even a declining one. So depending on the perspective, you see, of course, different outcomes. That's one thing. The second thing is also what you can see when you look in the upper part. There's a certain plateau that was reached in the 2010s, where there is no improvement anymore, but just a stagnant kind of behavior. And the authors argue here that this could be due to unaddressed stressors, diffuse pollution, for example, modification of the habitats. It could be due to intensifying stressors like climate change, and that's why I'm saying that here. And it could be also that emerging stressors like pesticides, pharmaceuticals, and so on could be the reason for that. Of course, there's more to do here and more to really investigate, and whether or not this is really the true factor behind the change. The main point I want to make here is that this is something eLTER, of course, wants to always support. And you need, for these kind of studies, the long-term data sets. And that is also where infrastructures come into play, because we do provide those long-term data sets. And again, this is what we will collect in the future as well, across the different sites and platforms. And before I forget, there's also, by the way, on the marketplace, a call for a follow-up of this study. So in case you happen to have information, data in that regard, please get also in contact with the ones who are behind this call. The second example I have here is the example that is more on the local scale, that really exemplifies the LTSER platforms, so the socio-ecology platforms. In this case, it's a study by Claudine Egger, who was using a so-called agent-based model, the SECNAT model, to project the future land use until 2015 on the climate and socioeconomic change. It's a bottom-up approach, and it's very important here. Bottom-up meaning that they have engaged in 32 structured expert interviews 1,329 farms in that region. So you can see on the right-hand side, the larger region, there are many farms inside, and they have engaged most of those 1,300 farms, which is quite an extensive approach, I would say. The main point being behind that that they argue that those current models do not really include the intrinsic motivation of the different farms and farmers. So what they really make or want to change, what they really want to focus on, whether it's whether it's an ecological, not ecological, but in whether it's an organic or a conventional approach, for example, whether or not they want to use modern land machinery or some old ones. So these kind of intrinsic motivation, the workloads, the working conditions they want to have, this would have been they should have been included this or wanted to include this because it does have a quite clear influence and impact on the decision making at the end. So they asked in those questionnaires the different farmers, what would you do under certain scenarios and conditions? And you see the scenarios on the right-hand side. There are three. One is the business as usual case. Everything will kept the same. And you have only moderate regional climate change additionally to it. Then you have a second scenario with the sustainability, which means there's more awareness from the consumers, which leads to rising demands in regional and organic agricultural products, a low input agriculture, and this is accompanied by mild climate change. And then you have rapid growth, which means there's an unconstrained economic growth and energy use. There's a strong climate change, which impacts even positively the yields, which leads to decreasing agricultural prices and some labor requirements. So all this, of course, is linked. And the question would be, what would you do in these kind of scenarios? And with this decision-based scenarios, they could then improve their agent-based model and got at the end these findings. And I'm just reading those bullet points here, and you can see some of them in the on the right-hand side. There's a massive decline of active farms with those scenarios over the years until 2050. So we go from 1,300 to only 850 farms, and even lower in the rapid growth scenario. There is a transition from agricultural land to forest. There's a transformation from intensively to extensively used grassland. There's an increase in the areas used for energy crops, and of course also there's a shift from after sedges to a mixed forest due to rising water scarcity and the associated bark beetle infestation. So everything that you can see here as finding is based, and that's the main point here, is based on the inclusion of the stakeholders. If that is not a central point in this segment model, in this bottom-up approach, these kind of findings would not be possible. In many cases, what we have is the exclusion of the stakeholders. We just simply do it in a top-down way. We do not really ask for what they need and what their requirements are and their problems are. So that's something we wanted to also in eLTER now focus on, include the stakeholder, ask for their needs, ask for their problems, try to find a service, try to find a solution for them directly. And now with this being said, I'm trying to bridge to what eLTER is doing in the IRISCC context, because one thing is a so-called service lab that we have, that is exactly what I just explained or tried to explain, where we use now this model concept from the last example that I've been given and try to bring this into service design lab into a pure service where the users can come, they can in a co-design process with us try to find a solution using the models the group has for this for the user directly. So to make their problem our problem and find a solution for them with them. So that's the first thing we do also on IRISCC, and this service, once being really operational, will also be, of course, provided by and through eLTER in the future. The second aspect is that also eLTER has, as ACTRIS, quite many sites and platforms in the transnational call in ACTRIS. Benyat has been saying about the last call, which has just been, I think, closed some days ago. The next one is going to be in July. You have the fast track as well. So I can only encourage you here to have a look at the page, find the right site, whether it's eLTER or some other RI sites and platforms. These are quite important, and they can also always assist you with what you have in mind. So again, I encourage you here also to look at the page and in case you happen to have an idea, apply. And the last thing is in the work package 4 that Nico is leading, also a demonstrator 3, which is on the risk on terrestrial ecosystem functioning and services due to droughts and heat waves. Behind that is actually a model that links the water and the carbon cycles to forecast ecosystem responses, to at the end be able to really inform agriculture and forestry domains, and also, of course, to help authorities secure food production and ecosystem services. Behind, as I said before, is a model, and it looks like that. That the output is a daily map like this, for example, where you can see directly the different severities of droughts in each of the regions across Europe. That's a daily map you can then use directly for that, and it is fueled, among others, of course, fueled by certain variables that come from ELTER and also from ICAR sites on soil moisture, for example, on evapotranspiration, gross plant production, leaf area index, and so on. So that is currently being set up, and I think, there's one also person in the auditorium who can be a bit more concrete here. I think in September is going to be the first version online available where you can test it as well. With that being, I think I'm at the end here. So I thank you as well for your attention, and I'm also open for questions now, of course. Back to you, Beñat.
Thank you very much, Ulf. That was once again a very comprehensive introduction to ELTER. I think it was also very interesting to say that ELTER covers this dimension that mixes the natural sciences with the social sciences through these ELTER or LTSER platforms. Once again, I just want to say thank you to Ulf, Nico, and all the participants in today's webinar. And we're going to stop the record now, and we're going to move to the questions. Just a quick reminder, check the catalog of services. Hopefully you can find something that is important for your research. And if you write down a proposal and the proposal is successful, you can get those services sponsored or paid by IRISCC. So don't lose this opportunity.